All right, so this is the last part for 9.3, and is with applications. So it says a square of two numbers add to 360. The second number is half the value of the first number squared. What are our numbers? Well, let's say, and again, we're going to have to set up our x's and our y's and stuff. So we have x is equal to the first, y is equal to the second. The square of them add to 360. So x squared plus y squared equals 360. And it says the second number is half the value of the first number squared. So the second number is y is half the value of the first number squared. Okay, so that's what we have there. Now, what do we want to do? Well, we have to solve this system of equations, basically. And I think what I can do is if I change and solve this for x squared, I can plug it in here. And so x squared equals 2y, because I'm going to multiply both of those by 2. Then I can substitute, and I get 2y plus y squared equals 360. Now I've got an equation, so basically I'm going to have to subtract 360 from both sides, and I'm going to have to factor. So I get y squared plus 2y minus 360 equals 0. All right, so I have to think of factors of 360. Okay, well, let's do this. 360, 2 is going to give me 180, 2 and 90, 2 and 45, 5 and 9, and 3 and 3. So now I need to, when I subtract them, I have to get a difference of 2. So I have 2, 4, 8, and 15. That doesn't work. How about 3 and 3 and 2 is 18 and 20. Okay, that works. And so what we're going to do is we're going to have a y and a 20 and a y and an 18. So 18 times 20 should give us 360, and 20 minus 18 is 2. And so we want the larger one to be positive, the smaller negative. That's equal to 0. So we get y equals a negative 20 or y equals 18. Okay. Well, what do we know about these values? What can we say? Well, if I plug in y as negative 20, that gives me negative 40 for an x squared. Well, you can't have a negative after you square it, so that one is out. But this one still is in because, 2 times 18 is going to be 36, so x is equal to 6. And, well, I just solved the question, I guess. So x squared equals 2 times 18. That's equal to 36. And so the square root. Now, again, we can only have, if the difference of the numbers or half one number is that, we can only have the positive here. We can't have a negative. And so that's just going to be x is equal to 6. So those are my two numbers, 6, 18, if I write it as a ordered pair, or just x equals 6, y equals 18. Now let's check. Does x squared, well, x squared is 36, plus y squared, 18 squared. Well, I don't know what 18 squared is. That's 64. That's 14. That's 8. That's 1. That's a 4. That's a 12. That's a 3. And that's a 324. If we add 36 to that, that's 10. That's a 6. That's a 3. That equals 360. That one works. And x squared is 36, and 2 times 18 is 36, so that one works. So that one is truly our solution there, 6, 18. What about the next one? Again, I wasn't sure if I would need more space. So here it says a cell phone company has the following cost and revenue functions. So we've looked at cost functions and revenue functions. This one is cost is 8x squared minus 600x plus 21,500. And R is minus 3x squared plus 480x. And what it wants to know is, what is the range of cell phones they should produce each day so there is a profit? And round to the nearest number that generates profit, okay? So how is that going to work? Well, one thing we might want to do is, what do these functions look like? So maybe we should graph these first. So I just want to do that to kind of get an idea. I won't look and see what the numbers are, but let's graph them and see what they look like. So the one was y equals, and it was 8x squared, and then minus 600x, and then plus 21,500. And the other one was y equals, and it was minus 3x squared, and then plus 480x. Okay, so those are my two graphs. Now, what do we know? It looks like they're all above, so we're gonna have to change our axes here. So maybe let's, okay, okay, we won't care what those are. It's the y-axis that we really want to do. So let's start at 0, and we're gonna have to go at least to 21,500. So maybe let's go to 30,000. All right. All right, so basically it looks like we're going to have parabola one way, parabola the other way. And I would say this one is going to be the negative 3x, and it is, it's purple. And so we want everything that's going to be, you know, kind of above that, and we want the cost function to be less than that. And so it's going to be, you know, somewhere in that region. So what we want is we want these endpoints. And again, that number doesn't tell them anything, and that number doesn't tell them anything. So I need to actually find the values. So if we go back to our PowerPoint slide, now what we're going to do is we're basically going to set each one of those functions equal to each other, and then we're going to solve for x, because that's the value we want. Because again, we had some cost function and some profit function. We wanted to maximize the profit, and then this isn't exactly how it was, and we want to minimize the cost. So if we're minimizing the cost, that's going to be here. If we're maximizing the profit, it's going to be over here, and that's kind of where they intersect. You know, you want to maximize where the cost and profit hit, and you want to minimize on this side here. Okay, so 8x squared minus 600x plus 21,500 equals negative 3x squared plus 480x. Okay, so I need to get everything to one side. So I'll add 3x squared and subtract 480x. So I'll add 3x squared minus 480x. And 8 and 3 is 11x squared. That's going to be minus 1080x plus 21,500, and that's equal to 0. Okay, now I'm not going to factor that. So that means we're going to use a quadratic formula. And so then x is equal to a minus b, and this is a minus already, so it's become positive, so 1080. And then plus or minus the square root of, probably have to go out pretty far here, and a minus 1080 squared minus 4 times a, which is 11, times c, which is 21,500, and then divided by 2 times 11. All right, 2 times 11, that's easy, that's 22. The rest of that, I'm going to have to go back and get our calculator out. And so let's go back to our calculator. And so let's do, we had the negative 1080, the quantity squared, and then we're going to have minus 4 times 11 times 21,500, and that's going to be underneath, so 22,040, so that's going to be underneath the radical, so it's going to be 1080 plus or minus the radical, and that was 22,400, and like I said, I knew that was 22. And so now we're going to have 1080 plus that divided by 22, and we're going to have 1080 minus that and divided by 22. So if we do the plus, that's going to be 1080 plus the square root of 22,400 divided by 22, and the minus, that's going to be a 1080 minus the square root of 22,0400 all over 22. So now we need to come up with those values. And so we're going to have 10, well, let's better put our parentheses here, 1080, and then if we did the plus one first, and then it's going to be the square root of that 22,0400, and then, oops, I don't want that there. I want out and then there, and then divided by our 22. And so 70.43, so that's going to be our upper. And then if we do second enter and do the negative or subtraction, it's 27.75. So 74.3 and 20. So this one was 70.43 and this one was 27.75 if I remember right. And so the range of cell phones is going to be between 27.75 and 70.43, and we want it rounded to the nearest number. And so that's going to be approximately, and we'll say 70, and this one's going to be approximately 28. Okay, so going from 28 to 80 is going to be the range. So the range per day, so each day produce between, and it's 28, and I'm wondering if these are actually thousands or something like that, because it doesn't make sense just to produce 28 things. I'm thinking it's 28,000, but it doesn't tell us that. And so 28 and 70 cell phones per day. Okay, and I'm thinking it's 28,000 and 70,000 based on this number here is in thousands. So I would think it's probably 28,000 to 70,000, because it doesn't make sense to only make 28 cell phones a day, and because that's just not that very many there. So I'm going with the 28,000 to 70,000 as the probable actual value they're looking for, but just in base terms on x's with what we're looking at, it's between 28 and 78. All right, so that's the end I have of section 9.3.